Welcome to Basic Thermodynamics class, Chapter 2. Topic name is Thermodynamic Process. So, in that chapter, we are discussing isothermal process and numerical problems related to the isothermal process. So, move to the next slide. So, in the last class, we discussed about the hyperbolic and isothermal process and the expression for the work done for the isothermal process. So, law governing the hyperbolic or isothermal process. So, isothermal process is also called as a hyperbolic process or the constant temperature process. So, isothermal process takes place at only constant temperature, means that a temperature difference dt is equal to 0. So, when this is a possible? So, it is possible only if expansion or the contraction, expansion or compression takes place slowly. So, when the temperature becomes equal means this is possible only when the expansion or the compression takes place very slowly, means that the heat exchange which takes place have the sufficient time to allow the temperature to remain constant, the heat exchange which takes place have then sufficient time to allow the temperature to remain constant. So, for a constant temperature process means it obeys the Boyle's law. It obeys the Boyle's law, means that the pressure is inversely proportional to the volume. As the pressure is increasing, the volume is decreasing. So, we can write this equation as a P1 V1 is equal to P2 V2 or P2 by P1 is equal to V1 by V2. So, PV is equal to constant, that is the Boyle's law. So, here we have is an important point is that where the dt is 0. So, the dt means the temperature we are putting as a constant. Temperature is a constant means T1 is equal to T2. So, change in temperature remains 0. So, that is why the change in internal energy is equal to 0 and change in enthalpy is also 0. Change in internal energy and change in enthalpy 0. Next, in this class we will discuss about the expression for the heat transfer and change in enthalpy during the constant process. So, we all know that as the temperature is a constant, because change in enthalpy and the change in internal energy is also 0 at constant pressure process. Some problems based on a constant temperature process, that is a isothermal process. So, hyperbolic is governed by which law? Means hyperbolic process is governed by the Boyle's law. PV is equal to constant. In yesterday's class, we discussed about the hyperbolic process. So, this is based on the Boyle's law. What is the Boyle's law stating? Putting the temperature as a constant, he conducted so many experiments. As the pressure is goes on increasing, the volume is decreasing, or vice versa. If pressure is decreasing, the volume is increasing. But PV is equal to constant. PV is equal to constant. Expression for the heat supplied or heat transferred. So, we can call as heat supplied or heat transferred. Heat supplied we are representing with Q1 or Qs thus. So, from non-flow energy equation we all know that dq is equal to du plus dw. dq is equal to dw means the heat supplied to the system from the surrounding is equal to the internal energy plus work done. So, here we are considering that it is in a isothermal process at constant temperature, du equal to constant temperature, internal energy du is equal to 0. So, then the equation becomes, so an isothermal process indicates that the heat supplied to a system, from its surroundings must equal to the work delivered to the surrounding. Thus, the non-flow energy equation for the isothermal process can be written as a Q is equal to W. So, thus in a constant temperature process, the heat supplied from the surroundings must equal to work delivered to the surroundings. So, this is the I am highlighting that constant temperature, the heat supplied. So, the heat, whatever the heat supplying from the surroundings is equal to the work delivered to the surroundings, work delivered to the surroundings. So Q is equal to W during the isothermal process. Isothermal process, we can write the equation as a Q is equal to W. So 1 to 2 process, Q1 to 2 is equal to W1 to 2. So the path of the process PV diagram will appear as a rectangular hyperbola, and hence we called as a isothermal process as a hyperbolic process. This hyperbolic process based on the Boyle's law. Boyle's law. So in the expression for the heat supply, whatever the heat we are giving to the system is equal to the work delivered to the surrounding. Q1 to 2 is equal to W1 to. Change in enthalpy. So change in enthalpy also, H2 we all know that H2 minus H1 is equal to mCp T2 minus T1. In isothermal process, we are putting as a temperature as a constant, means T1 equal to T2. So the change in enthalpy also is equal to 0. So substitute here T1 is equal to T2. So T2 minus T2 becomes 0. So anything into 0 becomes 0. So H2 minus H1 is 0. So thus in constant temperature process, the enthalpy remains constant. Since the dt is 0, the change in internal energy and the change in enthalpy is 0 in isothermal process. In isothermal process or constant temperature process. So in the last class we discussed the expression for the work done. So the work done formulas are, what is the work done formula? Work done is equal to, we can write in two ways. P1 V1 is log V, V2 by V1, or P1 V1 log P1 by P2, or we can write in terms of a P1 V1 in terms of a MRT. So work done is equal to MRT log V2 by V1 or MRT log P1 by P2. So this is the expression for the isothermal process, work done for the isothermal process. So we can write this expansion ratio as a V2 by V1 and the compression ratio as a V1 by V2. So just move on to the 0.05 meter cube of air at 1.2 bar is compressed isothermally. So in this condition they given it is an isothermal. So isothermal means you have to maintain the temperature as a constant. So I am highlighting is an isothermal. Isothermal to a volume of 0.016 meter cube. Determine the work energy required for the compression. So in the problem they clearly mention that it is an isothermal process. So isothermally means to recollect that there is a constant temperature process. So constant temperature process. So the given data V1 is equal to 0.05 meter cube, 0.05 meter cube, and the pressure 1.2 bar. So I am converting this bar into kilonewton per meter square. So already in the last class I told. So 1 bar is equal to 10 to the power of 5 Newton per meter square. So I am writing 10 power 5 as a 10 square into 10 power 3. So 10 power 3 I am writing as a kilo and square as a 120 into 100 becomes a 120 kilonewton per meter square. Next, volume. Next, compressed to a volume, V2 is equal to 0.016 meter cube. So the process is isothermal process. So for the isothermal process, the work energy required formula, what is the work energy? W is equal to, in the data they given the volume V1 and V2. So we write the equation in terms of a V1 and V2. In the problem, if they mention the pressures P1 and P2, write the equation in terms of a pressure. But in this problem, they given the data in terms of a volume. So I am writing the expression as a W is equal to P1 V1 log V1 by V2. Here the exponential log. In calculator, we have to do with the exponential log, log base E. So substitute P1 here. P1 is a 120, V1 0.05 log base E, V1 by V2. So by doing the calculation, we will got 6.837 kilojoules, because here we take the pressure as a kilonewton per meter square. So we will get answer in terms of kilonewton meter. So I am writing this Newton meter as a joule, Newton meter as a joule. So this is the first problem based on the isothermal process. So first read the question carefully and identify what is the and identify which process it is. So they mention it is in a clearly is in a isothermal process. Mention there is in a clearly isothermal process. So isothermally means constant temperature process. So first write the given data and write the what is the formula required. Where if the in the problem they given the pressure values, write the energy um, work energy equation in terms of a pressure, otherwise write the equation in terms of a whatever they given. Here they given in terms of a volume, so I am writing the equation W is equal to P1 V1 log E V1 by V2. W is equal to 120. Here the so many students will substitute 1.2 directly. It's a 1.2 directly means we'll get answer wrong. Here you are to convert the bar into Newton per meter square. So we know that 1.2 bar means 1.2 is into 10 to the power of 5 Newton per meter square. So I am writing 10 power 5 as a 10 square into 10 power 3. I am writing 110 square multiplying with 1.2 and 10 cube as a kilo. So 120 kilo Newton per meter square. So W is equal to 6.387 kilo joules. So this is the first problem completed. We move on to the second problem. So I am reading the second problem. So first read the question carefully and identify what is the process, whether it is a constant volume, constant pressure or constant temperature. First you have to identify which process is this and write the formulas whatever for that process and given data, and finally calculate what they asked in the problem. So here I am reading the problem. 0.0001 meter cube. See here 301 meter cube of air at 1000 kilonewton per meter square expands isothermally to a volume of 0.001 meter cube. The initial temperature is 25 degrees centigrade. Assume R value 0.297 kilojoule per kg Kelvin. Find the mass of the air, final pressure, work transferred, heat transferred. 0.001 meter cube of air at 1000 kilonewton per meter square expands isothermally. So what's the given the condition here? It is an isothermal process. So isothermally means it is a constant temperature process. Constant temperature process to a volume of 0.001 meter cube. The initial temperature is 25 degrees centigrade. Assume R value and calculate the mass of air M. We have to calculate the mass of air, final pressure P2 and the work transfer W and heat transfer dq. So first we have to write the given data. So what's the data given here is a volume 0.001 meter cube. So we are represented as a V1. Next, pressure. So kilonewton per meter square is the unit of the pressure. So P1 is equal to 1000 kilonewton per meter square expands isothermally. So the term isothermally means constant temperature process. T1 equal to T2. So T1 equal to T2. Volume V2 is equal to 0.01 meter cube. So initial temperature T1, so 25 degrees. I am converting into Kelvin. 25 plus 273, 298 Kelvin. So here the given is the process is isothermal, means temperature T1 equal to T2. So T2 is also 25 degrees centigrade plus 273 with 298 Kelvin. So R value 0.297 kilojoule per kg Kelvin. So first what they have to calculate the mass of the air. How will you calculate the mass of the air? First write the given data P1, V1, T1, V2, R value. So mass of the air. So this is the given data they given. So how do we get? So by using the ideal gas equation, PV is equal to MRT. So P1 V1 is, we know the P1, we don't know the P2. That's why we am writing this equation as a P1 V1 is equal to MRT1. P1 V1 is equal to MRT1. So in that we want only the M value. So M is equal to, I am bringing this RT1 as the left side. So it becomes M is equal to P1 V1 by RT1. So I am bringing this RT1 to the this side. We want only M value. That's why I am bringing this RT1 into this side. So it becomes M is equal to P1 V1 divided by RT1. So in the solution, in the given data, they given the P1 value. What is the P1 value? 1000. Next, V1 as a 0.0001. Three zeros. Observe that here three zeros. V2 is only two zeros. So here we have to substitute V1 0001, R value 0.297, T value 298 Kelvin. So with the calculator we can do the calculations and tell what is the mass of the air. Mass of the air. So we will get mass of the air after substituting all the values in the formula. So P1 1000, V1 0.0001, R 0.297, T1 298. We will get 1.13 into 10 power minus 3 kg. So units of the mass is kg. So here if you don't know the units and how to get the, you don't remember the units of mass, simply if you know the formula, if you don't know the unit of the mass, if you know the formula, simply substitute the units of the formula. P1 units. So I am writing the pressure units, volume units, R units, and the temperature units. We will get the mass units. So M is equal to pressure units. What is the pressure units? Kilo Newton per meter square. Kilo Newton per meter square. I am writing this meter square as like this. Kilo Newton per meter square into volume. So what is the unit of the volume? So volume unit is meter cube. Meter cube divided by R unit. So what is the R? Kilojoule per kg Kelvin. Kilo joule per kg Kelvin. So I am writing joule as a Newton meter. So we know that 1 joule is equal to 1 Newton meter. So I am writing joule as a Newton meter divided by kg Kelvin. Kg Kelvin. Capital K. This is for Kelvin. This is kilo. Small k is for kilo. Capital K is for Kelvin. And T1. So T1 is also Kelvin. T1 unit Kelvin. Capital K. So here I am cancelling first one. Kilo, kilo. Next, Newton, Newton. And here it is a meter square. Here it is a meter cube. I am cancelling 1 meter square. And the remaining is meter. And here 1 meter is there. Meter get cancelled. Kelvin, Kelvin get cancelled. So remaining is kg. Where the kg is in denominator, it is denominator. So we will bring upside. It comes to the here. So mass unit is kg. Mass unit is kg. So if you don't know the unit of the mass, so simply substitute all the units given in the formula in the data and substitute in the formula. M is equal to P1 V1 by RT1 and 1 joule is equal to 1 Newton meter. So 1 joule is equal to, I am writing that also, 1 joule is equal to 1 Newton meter. So we can convert this 1 joule as a Newton meter. 1 Newton meter. So here write the pressure units. Pressure units kilonewton per meter square, volume units meter cube, and R units kilo joule. Joule is 1 Newton meter by kg Kelvin Kelvin. So Kelvin Kelvin got cancel, kilo kilo get cancel, Newton Newton get cancel, meter square meter cube means 1 meter is there. So here 1 meter and 1 meter get cancelled and the remaining term is kg. This kg is it denominator of denominator. So it brings a, it gets go to the upside, in numerator is a kg. So this is the mass. So next what is we have to calculate after doing the mass, there is a final pressure. Final pressure means P2. So final pressure P2 can be calculated by using two formulas, So one is P1 V1 is equal to P2 V2 or P2 V2 is equal to MR T2. So I am using this formula. So you can use this formula also, will get both the answers are same. P1 V1 is equal to P2 V2 or P2 V2 is equal to MR T2. So we know V2 value they given in the data and mass we got from A bit, R value T2, T1 is equal to T2. So but in this I am using for finding the final pressure, I am using formula P1 V1 is equal to P2 V2. So we want the pressure P2. So I am writing this P2 is equal to, bringing this V2 to the left hand side, it becomes P2 is equal to P1 V1 divided by V2. So we have to do cross multiplication carefully. So P2 is equal to P1 V1 divided by V2. P1 V1 divided by V2. So we know the P1 value, V1 value, V2 value. Substitute all the values in the formula by seeing the data. P1 is equal to 100, V1 0.0001, V2 0.001. So see carefully. So both V1 and U2 are not equal. V1 0.0001 and V2 only 0.001. So by calculating we will get the pressure 100 kilonewton per meter square. Or by using this formula also we can get the P2 as the same 100 kilonewton per meter square. So P2 V2 is equal to MRT2. So they want only P2. So I am writing this P2 as a MR T2 by V2. So we know the M value 1.13 into 10 to the power of minus 3, R value 0.29 and T2 value 298, V1 value 0.01, 0.001. So we will get the same 100 kilonewton per meter square P2 value. These two formulas we will get the pressure. So we can use any formula. So students try with this formula. So P2 V2 is equal to MRT2. So by substituting all the values we will get the P2 value. And what is the third bit? Work transfer. So work transfer during the isothermal process means, here I am taking the work transfer in terms of a volume P1 V1 log E V1 by V2. Otherwise you can take the formula as a P1 V1 log E P1 P2 by P1 also. P2 by P1 also. P2 by P1 also. Here they given the compression. So the compression actual formula is P1 V1 log E V2 by V1 in expansion process. But here they given it is a compressed. So I am writing this formula as a P1 V1 log E V1 by V2. Log E V1 by V2. Substitute all the values here. 1000 into 0. 0001 log E value V1 by V2. So here it is a V2 is a V1, V2 by V1 0.0001 divided by V2 value 0.001, V1 0.0001. So we will get 0.2303 kilojoules. So V2 by V1, or we can write the formula as a P1 V1 log P1 by P2 also we will get like this, or we can write W is equal to P1 V1 log E P1 by P2, P1 divided by P2. So by using this formula also we can calculate the work done during the isothermal process, because we know the P1 and P2 also. So we can calculate, so we can get the answer same for using this formula, using the pressure formula or volume formula we can get the answer same 0.2303. So in the next problem what there is the heat transfer. Heat transfer means Q. So dq is equal to du plus dw, but in isothermal process du is equal to 0, but in isothermal process du is equal to 0. So whatever the work transfer is equal to the heat transfer. Whatever the work transfer is equal to the heat transfer. So dq is equal to dw. So q is equal to w 0.2303 kilojoules, 0.2303 kilojoules. So first write the given data and write the what they are asked and find what is the condition they given. Find the condition what they given. So it expands isothermally, not compressed. The given is an expands isothermally. So P1 V1 is equal to MRT1. From that we will got the mass value, and final pressure we will get by using the two formulas P1 V1 is equal to P2 V2. From that we will calculate the P2 value, or by using the P2 V2 is equal to MRT2 we can get the P2. Both the values are the same. After that we can is an isothermal process. Isothermal process W is equal to P1 V1 log V2 by V1 expands. They given the expands. If they given the compressed means we can write this as a V1 by V2. In the problem they given it is an expands means P1 V1 log V2 by V1. So substitute all the values by using the data and we will get the value W is equal to 0.2303 kilojoules. So after that what they as last bit heat transferred. Heat transferred is nothing but dq. So for the isothermal process the internal energy is a 0. For isothermal process internal energy is 0. Internal energy is du. So heat transfer is equal to work transfer. So q is equal to w 0.2303 kilojoules. So this is the another problem. So we move to the next problem. An engine cylinder of 75 mm diameter and 150 mm stroke contains 0.01 kg air at 15 degrees centigrade. Calculate the work required to compress. Here they given the compressed the air isothermally to a pressure of 700 kilonewton per meter square. Neglect clearance volume. So first read the question carefully. So what is the given? An engine cylinder of diameter. An engine cylinder of diameter. What is the diameter? 75 mm. Stroke length L. 150 mm. Mass 0.01 kg. Air at 15 degrees centigrade. 15 plus 273. You have to convert it into the Kelvin. Next, calculate the work required W question mark required to compress. So the given is the compressed air isothermally. Compressed air isothermally. Underline the what they given the condition. Here they given the compressed air. So W is equal to P1 V1 log V1 by V2 log V1 by V2 or P1 V1 log P2 by P1 because it is an isothermal compressed. So to a pressure of 700 kilonewton per meter square, neglect clearance volume. So first write the given Cp value and Cv value also they given. By using Cp and Cv values we can calculate the R value by using the relation Cp minus Cv is equal to R. You can calculate the R. I am writing the data. So diameter of this cylinder D 75 mm, length 150 mm. I am converting into the meters. 0.15 meters, mass 0.01 kg, initial temperature 15 degrees centigrade. I am converting into Kelvin. 15 plus 273 288 Kelvin. Work done W 122 question mark. Isothermal process means T1 equal to T2 is equal to T, and the final pressure 700 kilonewton per meter square. Final pressure 700 kilonewton per meter square. Clearance volume 0, Cp value, Cv value. So by using these two values we can calculate the R by using the relations R is equal to Cp by Cv. So 1.005 kilojoule per kg Kelvin minus 0.718 kilojoule per kg Kelvin. So we got as a 0.287 kilojoule per kg Kelvin. So this is the given data. This is the given data to calculate the work done in isothermal process. First write the data. Diameter, length, mass, temperature, and we have to calculate the work done. That's why I'm putting question mark. Temperature they given, pressure, clearance volume, Cp value, Cv value. So by using the Cp, Cv value we are calculating the R value. R value. So initial volume of the air is the cylinder volume. So pi by 4 d square L. So pi by 4 d square so we know that when the diameter and the length of the stroke given, volume of the cylinder is pi by 4 d square L. So pi by 4 they given the diameter in terms of mm. So we are converting mm into meters. So 0.075 meter cube into meter cube. So d square means 0.075 square into 0.15. So we will get 0.662 into 10 to the power of minus 3 meter cube. So it is a volume, that's why the unit is meter cube. So initial whatever the volume in the cylinder is the initial volume. So that is pi by 4 d square L. Diameter of this cylinder, length of the stroke. So 0.0662 into 10 to the power of minus 3 meter cube is the initial volume. We are representing with a V1. So how will you calculate the pressure? P1 is equal to MRT1. P1 is equal to MRT1. They given in the problem mass 0.01 kg and you know the R value and the T1 value. So by using the P1 is equal to MRT1 we can get the initial pressure as a initial pressure and 125.3 kilonewton per meter square. By using the relation PV is equal to MRT1, P is equal to MRT1 by V1. Substituting all the values in the ideal gas equation we will get the P1. So from the cylinder volume we got the V1 value. From the ideal gas equation we got the P1 value. So V1 is equal to V1 how will you get means pi by 4 d square L. P1 by using the ideal gas equation PV is equal to MRT. So I am writing PV is equal to MRT as a P1 V1 is equal to MRT1. So from that P1 is equal to mR T1 divided by V1. I am substituting all the values, mass, R value, gas constant, ideal gas constant value, initial temperature value, and initial volume, whatever you got in the in a bit 0.662 into 10 to the power of minus 3. So we got this a P1 kilonewton per meter square, because we take this R as a kilojoule per kg Kelvin. So that's why you got the pressure into kilonewton per meter square. Compression work, they given the compression work, so automatically it becomes a P1 V1 log V1 by V2, V1 by V2, or if it is an expansion work, it is becomes a V2 by V1. But in the problem they clearly mentioned it is an compressed isothermally. Compressed means isothermal compression work is happen, so P1 V1 is equal to log E V1 by V2, or we can write as a, or we can write W is equal to P1 V1 log, if you take V1 by V2, so here it becomes a P2 by P1, P2 by log E base E, log E base E, it becomes P2 by P1. So in the problem we calculate only P1 value, we don't know the P2 value. So if you want to calculate the P2 also, by using P2 V2 is equal to MRT2, we can calculate the P2 value also. We can calculate the P2 value also. Substitute here, we will get the value. So, but we know V1 V2 they given. So no, so use this formula, we will get P1 V1 log P2 by P1. So 125.3 V1 value log E 700 by 253, so 0.142 kilojoules. So we can use the two formulas V1 by V2 or P2 by P1. So if whatever the data given in the problem, based on the data we can write the expression for the work done in isothermal process, either P1 V1 log V1 by V2 or P1 V1 log E P2 by P1. So in this problem they given the P1 and P2 value, so that's why we are using P1 V1 log P2 by P1. In the place of a P1 V1 also we can use as a MRT1, we can use MRT1 also, MRT1 also, or MRT2, both we can use MRT1 or MRT2. So this is the answer for the work done during the isothermal process, during the isothermal. Next problem, 0.1 meter cube of air at a pressure of 1.4 bar expanded isothermally 0.5 meter cube. Calculate the final pressure of the gas and heat supplied during the process. So in the problem they clearly mentioned it is an expanded isothermally, means work done is a V2 by V1, P1 V1 log V2 by V1, expanded isothermally means positive V2 by V1, expansion ratio R is equal to V2 by V1, and it is in a constant temperature process, constant temperature process. V1 value, P1 value, here 1.5 bar, so converted into kilonewton per meter square, means 150 kilonewton per meter square V2, and calculate the final pressure P2 question mark, heat supplied means Q is equal to question mark. So I am writing the data first, given data V1 0.1 meter cube, P1 1.5, so P 1.5 into 100, 150 kilonewton per meter square, 150 kilonewton per meter square. Isothermal process means PV is equal to constant, V2 is equal to 0.5 meter cube, P2 question mark, heat transfer question. Next, final pressure P2, how will you get final pressure? So for isothermal process we know that P1 V1 is equal to P2 V2. So in the problem they given the P1 value, V1 value and the P2 value. So we want only P2 value. So bring this V2 into the left side and it comes to the denominator. So P2 is equal to P1 V1 divided by V2. P2 is equal to P1 V1 divided by V2. So P1 150, V1 0.1 and V2 0.5. So we will get 30 kilonewton per meter square. So final pressure is 30 kilonewton per meter square. And coming to the heat supply or work done. So work done W is equal to P1 V1 log. Here V2 by V1 because they as it is an expands isothermally. Expands isothermally means expansion ratio R is equal to V2 by V1. And we know pressure P1 and P2 also. So we can write this equation as a P1 V1 log E P2 by P1 also. But I am writing here P1 V1 log E V2 by V1 because they given in the data V1 and V2. P1 150 0.1 log 0.5 divided by 0. If you substitute here P1 by P2 also you will get the same answer. So you try itself. You put here by a P1 by P2. So 24.115 kilojoules. So but the problem in the problem that the heat transfer means dq is equal to du plus dw. So in the isothermal process means constant temperature, the internal energy is 0. So we can write this equation as a dw is equal to dq is equal to dw. In isothermal process heat supplied is equal to work done. So heat supplied dq is equal to dw is 24.115 kilojoules. 24.115 kilojoules. So in this also we can write the formula as a P1 V1 log P1 by P2. So we get the same answer 24.115 kilojoules. So we move to the next. So this is a very important problem for the 5 marks. So listen carefully. 1 kg of carbon dioxide is contained in a frictionless piston cylinder system during a reversible isothermal process. 26.4 kilojoules of heat energy is transferred out of the system. If the initial conditions of CO2 are 1.4 bar and 32 degrees centigrade, calculate work and the final pressure. Calculate the work and the final pressure. So 1 kg of CO2. So mass 1 kg and COT, frictionless piston cylinder during the reversible isothermal process. Isothermal process, they given it as an isothermal means constant temperature process. At constant temperature internal energy and enthalpy are 0. So dq is equal to dw. So heat energy rejected, heat energy is transferred, the given heat energy is transferred out. Transferred means heat is rejecting. How much heat is rejecting here? 26.4 kilojoules heat is rejecting. Read question carefully. 26.4 kilojoules of heat energy is transferred out of the system. So transferred out of the system, it is coming out of the system means that the energy is rejected. Energy rejected Q is equal to 26.4 kilojoules. Next, initial pressure P1 is equal to 1.5 bar, T1 32 degrees centigrade. So 32 plus 273, 305 Kelvin. So work done W question mark, final pressure P2 question mark. Work done W question mark, final pressure P2 question mark. Given data mass 1 kg, heat rejected. So heat rejected is Q is equal to minus 26.4 kilojoules. Initial pressure P1 1.4 bar, T1 32 degrees centigrade. Here they didn't given that the R value, but they given that the gas is a CO2. So R is equal to RU by M. R is a ideal gas constant value. They didn't given that, so we have to write. This is the given that is at in a carbon dioxide gas. So we know that R is equal to RU by M. So what is the M? M is nothing but the molecular weight of the gas. So CO2 is 12 plus 16. 12 sorry 32 plus 12, that CO2, O2 for carbon it is 12, oxygen 16, 2 molecules means 32, 32 plus 12, 44, 32 plus 12, 44. So 8.314 divided by 44, 0.189 kilojoule per kg Kelvin. So for isothermal process, they mentioned it is an isothermal process. For isothermal process, what is this? Internal energy dq is equal to du plus dw, where du is equal to 0. So dq is equal to dw. So second bit, what there is work done. So work done, w is equal to dq. W is equal to dq. For isothermal process, W is equal to Q, du means 0. Here W is equal to minus 26.4 kilojoules because heat is rejected due to the isothermal compression. So negative sign indicates due to compression. Negative sign indicates due to compression. So what is the formula for the isothermal compression? W is equal to P1 V1 log V1 by V2. For the compression, it is V1 by V2. For the expansion means V2 by V1. But it is we got the negative value. That's why heat is rejected due to isothermal compression. So I am writing the formula is that W is equal to P1 V1 P1 V1 MRT1. But in the problem they didn't given the V value. So how you can write? So we can write this formula as also as a MRT. In case of PV, we can write as a MRT log V1 by V2. So V1 by V2 for isothermal expression, W is equal to MRT log ln, or we can write as a log base E or ln, both are the same, log E base E V1 by V2. So we know W value, M value, R value, temperature value. Temperature also they given is 305 Kelvin, log base E V1 by V2. We know the values of V1 by V2. We don't know the values of V1 and V2. So substitute all the values here. We will get the ln V1 by V2 value. So 26.4, 1 R value, T value, ln V1 by V2. So this whole becomes to the denominator 26.4 divided by 1 into 0.189 into 305 becomes 0.4579. So log V1 by V2 this one. So we want V1 by V2 value. So this ln comes to this side means it comes to exponential form. V1 by V2 is equal to E power. This E comes to the this side. So it comes to E power 0.457. So calculate that by using calculator. We will get the V1 by V2 as a 1.5808. V1 by V2 as a 1.508. 1.5808. But in the problem they asked to calculate the final pressure. So how will you calculate the final pressure? So it is an isothermal process. By maintaining at constant pressure, we will get Pb is equal to constant. Means P1 V1 is equal to P2 V2. So we don't know the values of individual as a V1 and V2, but we know the ratio of V1 by V2. So I am writing the P1 by P2 is equal to V2 by V1. So we want P2 value. So move this P1 to this side. So it is equal to P1 V1 by V2. P2 is equal to V1 by V2. It is not by 2, it is a V2. V2. So we know the P1 value and the ratio of a V1 by V2. So P1 value is a 1.4, P1 as a 1.4, V1 by V2 as a 1.5802. So final pressure is 2.313 bar. 2.313 bar. So first what is that? We don't know the R value. So how to will get the R value? So R is equal to Ru by M. So universal gas constant Ru is the same for all the gases. So you have to remember that value also. Ru is equal to 8.314 and the molecular weight of CO2 12 plus O2 16, O2 means 32, 32 plus 12 44. So by using the formula R is equal to Ru by M, we will got the R value. After getting that R value, so the given heat is rejected. So Q value minus 26.4 kilojoules. So for the isothermal process, W is equal to Q. So we got the W as a minus 26.4. So what is the negative sign here? It indicates due to compression. So negative sign is work done due to the compression. So work done due to the compression, what is the formula? Work done due to the compression, W is equal to MRT log V1 by V2, log V1 by V2. So substitute the W value, m value, r value, t value. So we will got the log v1 by v2 value. Apply, move this log to the decimal means exponential form. So e is equal v1 by v2 is equal to e power 0.4579. So v1 by v2 is equal to 1.5888. So we want the pressure only. So pressure means how will you get P1 V1 is equal to P2 V2. So I am writing this P2 is equal to, we want P2 value. P2 is equal to P1 into V1 by V2. So 1.4 into 1.588. Final pressure is equal to 2.313 bar. So these are the problems related to the constant temperature or isothermal process. So in this period, we learn the expression of the heat transfer, change in enthalpy, and how to solve the problems on a isothermal process. How to solve the problems on isothermal. Next, do these two problems yourself. So what is the first problem? 0.4 kg of air at the pressure 1 bar and 20 degrees centigrade is compressed isothermally. Compressed isothermally means the work done will come as a P1 V1 log V1 by V2. So compression ratio R is equal to V1 by V2. M value 0.4 kg, pressure 100 kilonewton per meter square, T1 293 Kelvin, volume V1 0.08 meter cube, work done formula P1 V1 log V1 by V2. Here it is a compressed, that's why you can write as this V1 by V2. So they given the P1 value, V1 value and log V2 by V1. So by using P1 V1 is equal to P2 V2 or P2 V2 is equal to MR T22, we can calculate the V2 or P2. And also final pressure, final pressure how will you get? First, by using P1 V1 is equal to MRT1, calculate the either P1 or either P1 or V1. First calculate the work done. Next, by using the P1 V1 is equal to P2 V2, from that we will calculate the P2 value. Next, find the amount required to compress air at 15 degrees centigrade of 1 bar absolute when the compression is isothermally. Take R is equal to 0.29 kilojoule per kg Kelvin. So find the amount of required means Q. Q is nothing but the W. So can you calculate that W? Compression is isothermal. Here also they given the compression is isothermal. So work done formula you will get P1 V1 is equal to log V1 by V2. Or P1 V1 log V2 by P2 by P1 by P1. If you write the V1 by V2, we can write the pressure in terms of a P2 by P1. This is a compression means you have to write the formula as a P1 V1 is log V1 by V2 or P1 V1 log P2 by P1. So these are the problems related to the constant temperature or isothermal process. In the next class, we will discuss about the adiabatic process and the expression for the work done and the relations between the pressure, volume and the temperature. Relations between pressure, volume and temperature. So thank you.